You're listening to an Airwave Media Podcast.
Before we begin, I'd like to thank my newest patrons, Nita, Jennifer, and Ted. Thank you so much for your support. If you're not a patron yet, go check out patreon.com/historicalblindness, where for as little support as $1 a month, you get access to ad-free episodes, teasers, and exclusive content, my Blindside episodes, which will often continue and offer more insight into the topics I've been covering. Pledge support today and get the whole story.
Marketers, you know that feeling when your content just works? When you crush a viral trend before 10 a.m.? When one tiny tweak to a landing page sends click-through rates through the roof? That's Contentful. Dynamic content made blissfully simple. Contentful helps you create and launch personalized experiences instantly across any digital channel. No stress, no limits, only possibilities. Come get the feels at Contentful.com.
Hello, this is Matt from the Explorers Podcast. I want to invite you to join me on the voyages and journeys of the most famous explorers in the history of the world. These are the thrilling and captivating stories of Magellan, Shackleton, Lewis and Clark, and so many other famous and not so famous adventurers from throughout history. Go to explorerspodcast.com or just look us up on your podcast app. That's the Explorers Podcast.
On to the show. Welcome to Historical Blindness. I'm Nathaniel Lloyd, and I've traveled far through dense and remote wilderness to do science and solve a century-old mystery. In this episode, I take you with me on a breathtaking expedition to a primeval swampland where we will encounter a visitor from the stars. This is a story of cosmic horror, on a level of which H.P. Lovecraft only lurked at the threshold. The notion of an earth-shattering cataclysm hurtling out of the black void of the universe to end the era of man is a chilling one. In modern cinema, we might temper our feelings of powerlessness by imagining that our technology is up to the task of defending against a world-ending asteroid strike, as in the popcorn flick Armageddon. But at the same time, our sense of impotence in the face of such imminent death from beyond persists, as that same year saw a less optimistic version of the scenario in 1998's Deep Impact. This deep-seated dread comes not from knowledge or experience, as humankind has never experienced such a calamity before. We know a great deal about surviving earthquakes, hurricanes, tornadoes, and tsunamis, but not about the devastation of a massive celestial object impacting the Earth. And yet it has happened here before. Scientists believe that around 4.4 billion years ago, a planetoid the size of Mars collided with our world, casting off so much of our mass as to create our moon. And 65 million years ago, it is believed that just such an impact might have been the cause of the extinction event that eradicated the world's population of dinosaurs. So perhaps this foundational dread is inborn, part of our connection with the Earth and its longer memory. Or perhaps it is simply that our own exploration and scientific discovery has revealed things with which we struggle to be at peace. For we have uncovered the evidence, the bones of extinct creatures, the massive Chicxulub crater beneath the Yucatan Peninsula, and then there is the one more recent reminder of such devastating collisions, although this one lacks a discernible crater and remains mysterious in many ways. Thank you for listening to Terror over Tunguska, the Siberian blast of 1908. Just after 7 a.m. on June 30th, 1908, Semen B. Semenov sat on his porch enjoying a morning that must have seemed like many others. As a farmer in the Siberian village of Vanavara, he was no stranger to hard work, and likely had already been at it for some hours before taking a seat on his porch and admiring the day. Then before his eyes, the sky split open, and a ball of fire burst into his field of vision, a mass of flame roiling as it moved over the forest. Semenov felt the heat of that fire hit his face as if he'd just opened the door of a kindled wood stove. He scrutinized the fireball, trying to judge the size and nature of the thing. But just as quickly as it appeared, it vanished, for the sky suddenly darkened, as though the rift he thought he'd seen had clapped shut. A thud sounded from the forest, deeply felt through the earth, and then the forest, the fields, the very porch beneath his feet seemed to jolt as if struck by an impossibly sudden gust of wind, and Semenov's feet lost hold of the planks beneath them, and he fell unconscious. When he regained his senses, a great and furious roar, as of an entire fleet of ships discharging cannon fire, rattled his entire house, cracking its sturdy wooden frames and shattering the windows. Turning again to the skies from whence this destroyer had come, Semenov witnessed the birth of a massive black cloud rising from the forest, where burning trees could be seen to have fallen in great numbers and climbing ever higher into the once pleasant morning sky. Semenov was not alone a witness of this event north of the stony Tunguska River, about 40 miles or 65 kilometers from his village of Vanavara. Most of those who lived in that largely uninhabited region saw the fire, heard the terrible blast, and of course, they saw the haze that poisoned all the air and the towering smoky cloud, which filled the sky afterward, dropping a foul black rain as it sluggishly drifted over the land. In the aftermath of this fiery visitation, those who drew near that stretch of the stony Tunguska found countless burned trees, denuded of all branches, lying flat on the ground in parallel ranks, like fallen soldiers laid out after battle. Hunters found game scarce, and for a while, most went without venison, for more than 1,000 reindeer had been destroyed by the blast. Indeed, there were some known tribes of nomadic people who also disappeared. Entire roaming communities, whole families that were wiped from the face of the earth by that all-consuming fire from the heavens. Nor were the effects of this event experienced only by locals. Such was the magnitude of the blast. After Semenov and his house were battered by the shockwave, 400 miles away, the Trans-Siberian Express was similarly rattled, its engineer bringing the train to an abrupt halt when he saw the very tracks ahead vibrating like the tines of a tuning fork. Within 5 hours, London's barometers detected the shockwave racing through the atmosphere, and later they would detect it again after the ripple of the blast had gone all the way around the world and returned. And the towering dark cloud rising above the Siberian wastelands would continue, rising higher than any ordinary cloud, treating Central Asia and Northern Europe to glorious sunsets and strange illuminated nights so bright that Londoners reported being able to read their newspapers and take clear photographs at midnight, and sailors claimed to be able to see clearly for miles across benighted seas. The cause of this night sky illumination, it seems, was that the dark Siberian cloud had grown to such a towering height that it caught and reflected sunlight from beyond the horizon. It was clear to the world that some great atmospheric disturbance had occurred, but it was not clear what had caused it. The London Times, days later, suggested it was the result of some distant volcanic eruption, since it seemed so similar to the aftermath of Krakatoa's eruption 25 years earlier. But with no definite reports of volcanic activity, news of the disturbance seemed to fade and dissipate along with the massive cloud. While one might think that news from Russia, the developed nation closest to the blast, might have enlightened the world, Russia and all her peoples, scientists included, were preoccupied at the time. Only 3 years earlier, unarmed petitioners were massacred by Imperial Guardsmen at Tsar Nicholas II's Winter Palace, sparking the First Russian Revolution as mutinies among the military, strikes among workers, and general social unrest threatened the empire. This was followed by Russia's entry into the Great War, and thereafter by the revolutions of 1917, kicking off the Russian Civil War in 1918, which saw the Red and White armies clashing across Siberia, displacing tens of thousands of peasant farmers like Semyon Semenov. And while the violent warfare persisted, amid this refugee crisis, an outbreak of typhus spread, turning much of Siberia, already a harsh and desolate place, into a nightmarish hellscape, with swollen and mutilated corpses littering the streets and choking the icy rivers. Thus, it was not until 1921 that someone ventured out into the wilds of Siberia to investigate what had happened there more than a dozen years earlier. His name was Leonid Kulik, a former revolutionary who had survived 3 wars and imprisonment for his radicalism. By 1921, he was studying meteorites at St. Petersburg's Mineralogical Museum and planning an expedition into Siberia to search for impact sites. During his preparations, he found an old Siberian newspaper that mentioned the event of 1908, and he began a new line of investigation, piecing together several obscure news articles to assemble a narrative of that day in June, when Siberian peasants witnessed a strange fiery object traversing the morning sky on a horizontal and southerly trajectory, terminating in an enormous blast. Based on these vague and contradictory newspaper reports, Kulik set out that year on the Trans-Siberian Express to the town of Kansk, where he found no shortage of villagers willing to share their memories of that strange day. But he soon realized he was searching the wrong place and returned to St. Petersburg to further research the blast. So Kulik immersed himself in all the reports he could find from that year and any further research that had been done, consulting the work of geophysicists whose observatories had recorded the seismic and atmospheric disturbances that day. Based on their calculations, Kulik eventually recognized that the epicenter of the blast lay north of Vanavara and the stony Tunguska River, in the midst of a remote and swampy coniferous forest, or taiga. Kulik would not be able to mount another expedition until 1927, when he and an assistant made their way into the vast Siberian interior of the continent. It was a dangerous journey in a dangerous land. The winters were legendarily severe there. The swamps of the taiga were more easily traversable then, as they stayed frozen solid for 8 or 9 months, but one ran the risk of freezing to death themselves in that time of year. It is said that in those months, birds are known to fall out of the skies, frozen solid. But with the summer thaw came vast bogs, swarming with clouds of mosquitoes and flies, their brackish waters crowded with decaying tree trunks to the point that they became impassable. Thus, Kulik and his companion timed their departure such that they would be entering the taiga in the spring, hoping to avoid the pitfalls of both seasons. It proved to be months of travel, the most arduous being the final leg, as they penetrated the taiga itself on pack horses. After several days, fighting scurvy and other illnesses, they finally arrived at the site of the 1908 blast. It stretched on, impossibly vast, all the way to the horizon, an entire ancient forest smashed flat to the ground. Thick, old-growth tree trunks blackened by fire, snapped like toothpicks at their bases and thrown to the ground. To give some sense of the immensity of this blast, it has been measured at 2,150 square kilometers, or 1,335 square miles, with some 80 million trees destroyed. As Kulik surveyed the massive blast zone, he saw every tree parallel to the next, and as he further explored, he found the trees, which had been pointing south, eventually pointing north, indicating a radial pattern. Finding the center of this pattern, he expected to discover a massive crater, but instead, to his surprise, he found a grove of trees that still stood upright, although they were dead, blackened, and bereft of branches. He likened them to a stand of telegraph poles at the epicenter of the blast zone. Leonid Kulik would return to this site more than once in his life, always searching for a crater, for evidence of the meteorite that must have struck the Earth to cause this destruction. But he never solved this, the enduring mystery of the Tunguska event, an extraordinary blast with no apparent impact. Now for a brief intermission. Hi, listeners. Remember that the ads and sponsors of this program only contribute a small portion of the already meager earnings of this show. If you'd like to contribute to this project and help me turn it into a viable enterprise, remember that you can pledge support on Patreon at patreon.com/historicalblindness. For as little as $1 a month, you get access to an ad-free stream of the show that also includes teasers and fully produced patron-exclusive bonus episodes. And at higher tiers, you can get early access to episodes and other perks. Become a patron of the show today and get the full story. Every summer, I'm careful to avoid getting burned. My summer plans always include applying sunscreen so I can attend barbecues and protests without worrying about getting scorched. And when I make my plans by making phone calls, I also don't want to get burned by an outrageous wireless bill. That's why I switched to a Mint Mobile plan and saved enough to take a summer vacation. With Mint, I found no difference in speed or coverage, just a big difference in cost. And right now, you can switch to a Mint wireless plan like me to avoid sweating those surprise charges and overages. You'll just be chillin' with Mint's offer of 3 months premium service on the nation's largest 5G network for just $15 a month. With high-speed data and unlimited talk and text, it might just be the coolest thing happening this summer. This year, skip breaking a sweat and breaking the bank. Get this new customer offer and your 3-month unlimited wireless plan for just $15 a month at mintmobile.com/blindness. That's mintmobile.com/blindness. Upfront payment of $45 required, equivalent to $15 a month. Limited time new customer offer for first 3 months only. Speeds may slow above 35 gigabytes on unlimited plan. Taxes and fees extra. See Mint Mobile for details. As listeners of Historical Blindness, you're no strangers to the fact that history is a lens through which we can better understand the present. Or as Shakespeare put it, what's past is prologue. History is the indispensable context without which we cannot hope to truly understand current events. You understand that, and so do the creators of the American Scandal podcast. Every season, they immerse listeners in the biggest controversies in U.S. history, helping us understand America's dark side and learn from its troubled past. Its latest season, Ruby Ridge Standoff, delves into an incident that sowed the seeds for the rise of the modern radical right. It transports you to 1992, where in a remote corner of Idaho, federal law enforcement surround a small cabin. They've come for Randy Weaver, a survivalist who took his family to the mountains in anticipation of the apocalypse. A simple weapons charge brought the agents here, but the situation is about to explode into a deadly and tragic standoff that will later become a rallying cry for far-right extremists, fueling distrust and violent anti-government sentiment for decades. Follow American Scandal on the Wondery app or wherever you get your podcasts. You can binge all episodes of American Scandal's Ruby Ridge Standoff early and ad-free right now on Wondery Plus. Now, back to the show. The mystery of what came out of the sky on June 30th, 1908 persists even today. Expeditions by scientists to the blast site have been continuous. Kulik himself, as previously stated, made several more, but in 1941, at 58, he became involved in his fourth war, and this one he didn't survive, dying in a prison camp in 1942. Scientific advancement in the 50s and 60s and afterward saw further interest renewed in the site. Of course, the prevailing theories focused on a comet or meteorite strike, but the lack of impact crater confounded these and gave rise to various intriguing alternative theories. In 1946, Russian war veteran and science fiction author Alexander Kazantsev hypothesized that an alien spacecraft, from Mars obviously, had visited Siberia in order to retrieve water from Lake Baikal, and ended up exploding in the air over the taiga. His theory was born of the atomic age and was inspired by a visit to Hiroshima, so Kazantsev speculated that the craft detonated in a nuclear explosion, irradiating the area below. No evidence of high radiation levels have ever been found to support the theory of a nuclear explosion, however, so this notion, with its concomitant belief in extraterrestrial visitation, has only been embraced by ufologists and writers of science fiction, among whom the Tunguska event has become a mainstay. This marks the beginning of a pattern in thought on the Tunguska event, though. Just as the atomic age and the era of UFO sightings led to this unique new theory about the Siberian blast, so whenever a new notion in science emerged, it was applied to this mysterious incident. In the mid-60s, a new theory emerged positing that a chunk of antimatter had struck the Earth in 1908. In like fashion, this story seems to have arisen from the popularity of the concept of antimatter at the time. The idea of negative matter can actually be traced back to the late 19th century to outmoded scientific theories, such as the vortex theory of gravity, which in the 1880s led William Hicks to propose the existence of matter with negative gravity. The existence of luminiferous ether, a long-standing theory of the substance filling what seems to be empty space, remained scientific consensus in those years, and despite proofs of its non-existence, like the results of the Michelson-Morley experiment, it would not be done away with until Einstein's contributions. When applied to the understanding of the atom, ether theory led Carl Pearson in the 1890s to suggest the existence of ether squirts, which notion itself, quote, would involve the existence of negative as well as positive matter in the universe, end quote. But it wasn't until the 1920s and the work of Paul Dirac that we draw near the modern notion of antimatter as negative particles. Then in 1932, Carl Anderson scientifically confirmed their existence, discovering and naming the positron. A couple decades later, in 1955, Emilio Segre and Owen Chamberlain discovered the antiproton and won the Nobel Prize in Physics. Thus, in the 1960s, the interest in antimatter was high, and another Nobel Prize-winning scientist, Edward Libby, developer of the science of carbon-14 dating, put his weight behind the idea that the Tunguska event may have been an example of antimatter and matter colliding. As proof, they cited radiocarbon evidence from tree rings formed in 1909. However, they collected their data from just 2 trees, an oak in LA and a Douglas fir in Tucson. A few years later, the Condon Report on UFOs, which reinvestigated Project Blue Book data for the Air Force, revealed the findings of several scientists that there was not enough radiocarbon evidence to support this theory, and that the impact of an object containing antimatter may actually be impossible to confirm, as we have no evidence that the antimatter itself would leave any trace. Just as scientific preoccupation with antimatter led to ideas of an antimatter collision, so in 1973, when the scientific community was fascinated by black holes, a new theory regarding the nature of the Tunguska event was spawned. This one, however, would have seemed quite far-fetched before very recent scholarship, for black holes were known to be enormous deformations of space-time, where gravity is so strong that no matter would escape. Surely a black hole would condense, pulverize, and destroy the Earth as we know it, for it was thought that only a mass the size of a star could form a black hole. Then along came Stephen Hawking at Cambridge to show the world that the Big Bang may have created black holes of varying sizes, some perhaps even very small. And as study of the phenomena progressed, it was speculated that large black holes could fragment into smaller ones if they collided with each other. So arose the notion that the object that Semenov saw roaring out of the sky in 1908 was not a comet or asteroid, but a black hole. As this theory goes, the mass at the center of the black hole would only have been the size of a few atoms, and the collision of its gravitational field with our atmosphere could have caused the great disturbance that witnesses saw. Despite all this sound and fury, however, proponents of this theory insisted the black hole would have passed right through the ground, through the entire Earth itself, and would have emerged on the other side of the globe, through the Atlantic Ocean, raising a great column of water and leaving behind a massive shockwave. The problem here was that no such disturbance was recorded in the Atlantic that year. While these colorful theories have come and gone, the abiding theory is that a comet or an asteroid struck the Siberian taiga that day. The lack of an impact crater has always confounded this simple theory, though, for if an object of the size scientists believe this object must have been actually struck the ground, there would have been a massive displacement of the Earth, and there certainly wouldn't have still been trees standing upright at the epicenter of the blast radius. So taking a page from Kazantsev's science fiction, they rely on the idea of an airburst. And this appears to resolve the problem. Under great pressure from penetrating the atmosphere, the object exploded above the ground. The force of the blast directed downward because of its trajectory, charring the trees directly below it, but leaving them standing as the shockwave then hit the ground and spread outward, burning and knocking over the trees in its path as it moved away from that stand of blackened telegraph poles. But what was it? There is a big difference between a comet and an asteroid. A comet is composed primarily of ice and dust, so the idea that it would detonate and disperse completely under the heat and pressure of entering the atmosphere is understandable. And it's true that a comet might strike the Earth at far higher velocity than an asteroid because they circle far from the Sun on longer orbits, so even a small comet might make for a far more destructive collision. But because of their longer orbits, comets are far less likely to strike the Earth than asteroids. In fact, we have no direct evidence that a comet has ever hit Earth, although recently we did confirm that such a collision can happen when in 1994 observatories witnessed a comet crash with great violence into Jupiter. Due to the rarity of comet impacts and evidence from computer simulations that suggest a comet would explode too high in the atmosphere to be the cause of the blast, science tends to favor the notion that the Tunguska event was caused by an asteroid. What kind of asteroid, however, proves to be yet another mystery. An iron asteroid, once part of some planet's core, would be so dense as to explode too low or not explode at all, resulting in a crater and a meteorite remaining behind for study. As this doesn't appear to be the case, many scientists believe it to have been a common stony asteroid, once part of some planet's crust. The fact that such a stony asteroid might have been vaporized in its explosion does not necessarily mean, however, that no trace of its extraterrestrial material remained. In fact, some Soviet investigators in the late 1960s believed they discovered such remains. In soil samples taken from the blast site, they uncovered a number of shiny black metallic spheres with magnetic properties. Analysis of their distribution appeared to indicate that they were associated with and perhaps formed by the blast. These microscopic spheres were studied for more than a decade, and by the 1980s, high-sensitivity neutron activation analysis indicated they were extraterrestrial in nature, specifically due to their richness in iridium. Moreover, testing of Antarctic ice layers dated to 1908 also show higher levels of iridium, indicating that this meteoritic debris traveled the world over after the towering cloud over Tunguska carried it into the stratosphere. But still, as always, experts disagree, staking their professional reputations and careers on a variety of alternative theories. A group of Italian scientists, for example, have traveled to Siberia to take samples from the bottom of Lake Chaco, a small lake very near the epicenter of the blast, which because of its shape has been speculated to be an impact crater, perhaps for a piece of the asteroid thrown aside by the airburst. The Italian investigators discovered the lake to have funnel-like dimensions, unlike most Siberian lakes which have flat bottoms, and this shape further encouraged the idea it had been created by an impact. The amount of sediment on the bed of the lake seemed to indicate it was older than 1908, but their study of the sediment indicated a difference between its topmost layers and those beneath, and underwater video showed what appeared to be trees buried in the sediment. Moreover, old 19th century military maps showed no sign of the lake, and testimony from natives corroborated the idea that the blast had created it. And most tantalizing, their seismic and magnetic analysis returned indication of an anomalous magnetic rocky object beneath the lake that they believe may be the culprit, a fragment of the Tunguska object. Further studies by Russian scientists have continued to dispute this theory, though, showing through radiometric dating and analysis of sedimentation rate that the lake is significantly older than the Tunguska event. So, as with all enduring mysteries, disputes persist. Indeed, I have not even taken the time to discuss the opposing school of thought that the Tunguska blast was a completely terrestrial phenomenon, the result of a natural release of methane gas from the swampy taiga, perhaps due to the underground formation of a kimberlite deposit. If a massive plume of methane were ignited, it would certainly create an enormous fireball, although witness statements clearly indicate the fire they saw descending, not ascending. Nevertheless, this view of the event is so popular that in Moscow, on the anniversary of the Siberian blast, scientists who subscribe to competing views of its cause attend separate conferences on the same day. Yet regardless of this schism in the scientific community, in the popular imagination, when one thinks of the Tunguska event, one thinks of some cold cosmic body hurtling out of darkness to smite our living Earth. The thought is enough to cause an existential dread, especially when one considers that such impacts may not be as rare as we would like to believe. In 2013, a meteor the size of a 6-story building screamed across the sky over Chelyabinsk, Russia, and detonated with the strength of a nuclear explosion, shattering countless windows and injuring 1,200 people. Then, just last year, in December 2018, another meteor exploded, this time over the Bering Sea. No one noticed at the time, but satellites observed it. And we're only now coming to realize the strength of the blast, which rings in at 173 kilotons, 10 times that of the bomb dropped on Hiroshima. It is unsettling, to say the least, to think that if either of these objects had exploded closer to the Earth, or God forbid, impacted, then we might have had an event of such devastation that only the Tunguska blast could stand as its precedent. And of course, in the case of Chelyabinsk, with its population of over 1 million, it could have been far, far worse. Thanks for listening to Historical Blindness, the Odd Past podcast. I want to thank my brilliant partner patrons, Marina, Joe, Michael, Jacob, Robert, Diane, and David. You're the light in the sky by which I do my midnight reading. Some music on this episode was provided by film composer Alex Kish. Check out his work at alexkishmusic.com. While you're online, visit the blog at historicalblindness.com to see images and find links to further reading and citations for academic sources. You can also find book recommendations for almost every episode topic on the Books tab, as well as a link to my own book, Manuscript Found, a historical novel about the rise of the anti-Masonic political party and the composition of the Book of Mormon. If you liked the episode or are a fan of the show, give it a rating and review wherever you can, especially on iTunes. And follow on Twitter, Facebook, and Instagram. Until next time, remember to keep your eyes peeled for rogue fireballs. You could end up being the only witness of history in the making.
This is Jen
and Jenny
from Ancient History Fangirl, and we're here to tell you about Jenny's scorching historical romantasy based on Alaric of the Visigoths, Enemy of My Dreams. Amanda Boucher, best-selling author of the Kingmaker Chronicle, says, quote, "This book has everything: high-stakes action, grit, ferocity, and blazing passion. Julia and Alaric are colliding storms against a backdrop of the brutal dangers of ancient Rome. They'll do anything to carve their piece out of this treacherous world and not just survive, but rule."
Enemy of My Dreams is available wherever books are sold.
What does Sputnik have to do with student loans? How did a set of trembling hands end the Soviet Union? How did inflation kill moon bases? And how did a former president decide to run for a second non-consecutive term? These are among the topics we deal with on the My History Can Beat Up Your Politics podcast. We tell stories of history that relate to today's news events. Give a listen. My History Can Beat Up Your Politics wherever you get podcasts.